Hello everyone, welcome to the Cam Zone channels, my YouTube channels. Okay, myself Dr. Amiz Banjare. Today I'm discussing for this for electrochemistry. So what is your electrochemistry? Which types of working for this for electrochemistry? Okay, generally normal introduction for this for electrochemistry and definition for this for basic explanations. Okay, basic explanation of an electrochemistry. First one is your electrochemical cell. Second one is your oxidations and reductions. What is the meaning of oxidations? What is the meaning of reductions? Then energy from the chemical reactions, which energy are providing for this chemical reactions. Second one is a concept made by the with examples. Okay, with example from this word concept. Okay, I'm providing for this word some examples. Okay, electrochemistry. So basic points are present. Okay, key points electrochemistry are key point is your redox reactions. Okay, redox reaction means both chemicals are present in one single chemical, means oxidation and reductions both are present in one single chemical reaction. This called is your redox reactions. And battery technology, two types of in a battery are present. First one is a primary battery, second one is your secondary battery. Okay, it's a dry battery and your liquid battery. Then electrolysis, yeah, electrolytic, both are same. Okay, okay. So first starting for this word electrochemistry. What is the electrochemistry? Okay, so what is the electrochemistry? Electrochemistry. Okay, so that is a theoretical part. So electrochemistry is a branch of chemistry. Okay, electrochemistry is a branch of chemistry with deal with the transformation of electrical energy to chemical energy. I mean to say that is a short form. So electrochemistry is a branch of chemistry. Okay, that is a parts of chemistry. And this one electrochemistry meaning is a transfer of our electrons. Okay, means energy. Electrical energy to chemical energy and chemical energy to electrical energy. That is what parts of electrochemistry. Okay, then that is the chemical application of electricity, and that is the providing for this chemical energy. Okay, in applications. So first one is scope of your electrochemistry. You can see for this one, first one is your scope in your future scopes. First one is study of, okay, first one is study of relationship between electricity and chemical reactions. That is a relationship, both are chemically relationship, electrical energy to chemical energy. Second one is your conversion of electrical energy into chemical energy. That is your conversion, changing of forms. Conversion of electrical energy to chemical energy. Third one is your conversion of chemical energy to electrical energy. That is what changing of in a form. Okay, I would say exchange chemical to electrical and electrical to chemicals. Okay, that is what changing of in a form means. Chemical, that is a reversible reactions. Okay, I mentioned for these two arrow lines. Okay, chemical to electrical and electrical to chemical, that is a reversible process. Okay, then next one, fourth one is the application of their conversion of device in device and industrials. Okay, that is the parts of using for this industrial series. Okay, then next one is your measures area. Three measures area are present. First one is your, okay, first one is your electrochemical cell. Electrochemical cell, that is an example for this for galvanic cell. Electrochemical cell is a galvanic cell. Electrolytic cell. Second one is your electrolysis cell, and that is a parts of the electrolytics. Okay, electrolysis and electrolytic both are same. Okay, example for the electrolytics, refining, then extraction of metals. Extraction of metals, that is a purification of metals molecules. And third one is your battery and fuel cell, battery technology and fuel cell. So two examples of first one is a primary battery, second one is a secondary battery and fuel cell. And fourth one is a coercions and its preventions. Okay, coercions means जंग लगना, normal language बोले तो जंग लगना, लोहे पे जंग लगना. Okay, so that is the example for the rusting of metals and protect coating. Okay, rusting means जंग लगना. Then protect, किसी टाइप्स का हमको क्या करना है, उसको प्रोटेक्ट करना मीन्स आयंस के फॉर्म में प्रोटेक्ट करना, या हम उसको पेंट भी कर सकते हैं, पेंटिंग ऑफ आयरन मॉलिक्यूल्स. Okay, third importance and applications. Okay, production of production and purification of metals. Okay, electrochemistry generally using for the any types of productions and purification of metals molecules. Second one is your manufacturing of chemicals. Which chemicals are manufacturing? That is, the examples are present: sodium hydroxide, chlorine and hydrogen molecules. That is the manufacturing of chemicals. Third one is your working of battery, accumulated and fuel cell. That is the battery technology. Then fourth one is your prevention of corrosions and improving the life of metals. Prevention of corrosions and improving of the metals life. I mean to say, you are coating of the metals and these metals are लाइफ ड्यूरेशन विल बी इंक्रीज. अगर हम उसमें क्या करते हैं, जंग लगी हुई है या जंग लगने से हमको बचाना है, उसको पोइजन से बचाना है, तो हम क्या करते हैं, पेंट लगाते हैं. जनरली सभी लोहे की जो चीजें होती है उसमें क्या करते हैं, हम पेंट लगाते हैं, जिससे हमको क्या कर सकते हैं, उसको प्रोटेक्ट कर सकते हैं. Then next one is your analytical applications. Okay, pH measurement and conductivities. Okay, generally pH measurement and conductivity and measurement. Okay, analytical applications. And that is a briefly explanation of an electrochemistry. Okay, electrochemistry deal with the incursions of electrical energy and chemical energy and these practical applications, various device. Okay, that is the practical applications and various device, process and industries. Okay, that is the parts of our electrochemistry. Then second one, exploring the principle of electrochemistry. Okay, that is the electrochemistry. Two types of electrochemistry are present. First one is your electrolytic cells. Okay, electrolytic cells. Second one is your electrochemical cell. Okay, that is the two direction of electrochemistry. You can see for these two directions. Okay, two direction of your electrochemistry. So left hand side I mentioned for this were electrolytic cells and right side mentioned for this were electrochemical cell. Okay, so this one electrolytic cell is the electrical energy to chemical energy. These energy are converting for the electrical energy to chemical energy. Okay, so electrochemical cell are working. Okay, electrolytic cell are working as well electrical energy to chemical energy. That is your correct. Okay, electrolytic cell is the electrical energy to chemical energy, and that is the conversion of your form. Second one is your electrochemical cell, that is your chemical energy to electrical, just opposite, means that is your chemical energy, so that is a form of changes. Okay, chemical energy to electrical energy and electrical to chemicals. This one electrochemical cell, that is the working for electrochemical cell. Electrochemical cell are working for the chemical energy to electrical energy. Okay, you can see for this I have mentioned for this one electrical energy converted to chemical energy. Okay, that is the forms are present. Next one is where electrochemical cell. Okay, electrochemical cell. Okay, what is the electrochemical cell? So electrochemical cell, the first one electrochemical cell, that is converted of chemical energy into electrical energy through the spontaneous redox reactions. Okay, that is spontaneous reactions. Okay, means electrochemical cell are working for this, for changing for this, for energy in a chemical energy to electrical energy, chemical energy to electrical energy, and that is a spontaneous process. Spontaneous means स्वतः, independent, खुद से होने वाला process. That is where spontaneous chemical reactions. Okay, and you can see for this diagram, two chambers are present. Okay, I mentioned for this A and B. I mentioned the nomenclature A and B. Okay, A and B. A side is your A side are present for the zinc sulfate solutions, and B side represent for this your copper sulfate solution. Okay, CuSO4 and ZnSO4 solutions are present. Okay, and left hand side A sections are present for this Zn zinc, and right hand side represent for this for copper, that is the electrode. Okay, that is the electrodes. Two electrodes are present, left hand side are present for this your zinc electrode and solution will be used in your zinc sulfate solutions, and right side represent for this your copper electrodes and solution will be used for this your copper sulfate solutions, and that is the mention for this your charge positive and negative. So left hand side zinc side, okay, zinc electrodes are represent for this your anode form, and that is this one is the chemical reaction is the oxidation chemical reactions, and the right side are present copper side are present for this were cathodes means positive ions, okay, and then anode means negative ions, positive and negative ions both side are present, positive and negative, okay. Then center point, okay, you can see for the center side that is the u shape structure opposite u, okay, u that is the u that is this size of an u structures, and this one is the opposite, okay, opposite means this side u, okay. So u structure that is your salt bridge, and what is the working for this word salt bridge? The salt bridge working for this word transfer of your solutions, and you can and transfer of your ions, and this salt bridge are present for this word potassium chloride solutions also present in your salt bridge, and this salt bridge are working for the transfer of your ions molecules, okay. And you can see for this one left hand side to right hand means a to b sides our electrons are transfer. I mentioned for this arrow, that is mentioned for the one single arrow, and transfer of your left hand side to right hand side of your electrons. Then next one anode. Anode chemically reaction for this your zinc. Zinc is your solid form because that is your electrodes, and solid is your remove for this our two electrons in your outermost orbitals. Okay, two electrons are removed, दो इलेक्ट्रॉन इन्होंने क्या किया बाहर निकाला, जिसके कारण से इसमें क्या हो गया हमारे पास जेड एन प्लस टू चार्ज के फॉर्म इसमें आ गया और टू इलेक्ट्रॉन्स यहाँ पे बाहर निकली हुई है, इसका मीन्स क्या होता है रिमूव ऑफ इलेक्ट्रॉन्स, okay. Then cathodes, that is a reduction process, and that is a gain of electrons, two electrons are added, that is the reduction process. Then overall chemical reactions, okay, this chemical reaction, overall chemical reaction is your redox reactions, okay. Redox reactions means both are present, okay. Oxidation and reduction, both chemical reaction are present in one single chemical reaction, okay. So this called is the redox reactions, okay. The next one, what is the energy conversion? Energy conversion is what electrical energy converted to, sorry, chemical energy converted to electrical energy. Nature of reaction, that is what spontaneous swatah reactions, and anode and cathode sign will be present means positive and negative signs are present, okay. Then Q point, you can see for his upper side that is the key points, okay. Anode is your negative, and this one working for this for oxidation process. Cathode is your positive, and this is working for this for reduction process. Then third one is your electron flow for the anodes to cathode, okay. You can see anode to cathodes electrons are transferred, anode to cathode electron transfer, okay. Then next one is your salt bridge, maintain the electrical neutralities, okay. So salt bridge are working to maintain the neutralities of solutions. Which solutions? Zinc sulfate solutions and copper sulfate solutions. And these solutions, zinc sulfate and copper sulfate solutions, are distributed for the two parts. Okay, these solutions are distributed for these two parts. So zinc, okay, these are mentioned for the zinc sulfate are distributed for the two parts means zinc plus 2 charge and sulfate minus 2 charge, okay. Zinc sulfate and copper sulfate, so okay, zinc and sulfate ions is your sulfate minus 2 charge, okay, distributed for the two parts, okay. Same condition apply for this for copper sulfates. Then next one is your electrolysis cell. Electrolysis cell, what is the electrolysis cell? Okay, then okay, then next one is your remembers, okay. Electrochemical cell make the electricity from that is your spontaneous chemical reactions. Then next one is your electrolysis cell, electrolysis cells, then electrical energy to device, okay. Electrolysis cell electrical energy to device is not in spontaneous reaction, that is a not in spontaneous reaction means यह स्वतः कार्य नहीं करता या independence नहीं होता, okay. You can see for these chambers, okay, you can see for this diagram in a using for this one copper sulfate solutions and two electrodes are used, any two electrodes not mentioned for the any names, okay. That is the normal structures. So anodes are working for this oxidation process and cathodes are working for this reductions process. Okay, same condition applies, same chemical reaction for your electrochemical cell and electrolytic cells. Okay, anode is your working for this your oxidation process and cathode is working for this your reductions process. And key point is you require the extra power circuit. Okay, that is what require the extra power circuit because that is a electrolytic cells is a not as your this one is a not spontaneous batteries. Then second one is your anode is a positive, then there is a oxidation process and cathode is a negative and there is a reduction process. Then electrons are pushed by power supply. Electrons are pushed by the power supply. Okay, that is a present for the DC supply, DC power supply, and that is a battery structure positive, negative, and that is a represent. Okay, extra power will be generated for the forms. Okay, so electrons are pushed by the power supply. Okay, electrons putting pressurized. Okay, push the powers of negative to positive inside of cells. Okay, next one is use of the electroplating, refining metals and electrolytics of compounds. Okay, then applications, different types of applications are present. First one is your battery. This one is your using for the batteries form. Second one is your fuel cell. Second, third one is your sensors, using for the sensors in your electrolytic cell. Fourth one is your electroplating, means covering coating of your any metals molecules as any types of metals molecules are coating. The next one is your electro referring. Okay, electro referring. Then next one is a protect of your production of chemicals. That is the production of chemicals, means formation of any types of the chemicals. Then remember topics main importance, electrolysis cell using for the electricity make a not spontaneous reaction. That is a not spontaneous chemical reactions. Next topic is your types of conductors. Yeah, semiconductors theory. Okay, so generally three types of forms are present: electrical conductors, semiconductors, and non-conductors. I mentioned for this your numbering 1, 2, and 3. Okay, conductors means all the metals are passes throughout the pass of an electrical energy, means electrons transfer of an electrical energy. All the metals. Example for this were gold and copper wires. Graphites also, that is where parts of your conductors is the transfer of electricity. Then fused salt, molten salt means NaCl, sodium chloride solutions. Yes, any types of sodium chloride are passes the fused salt. Then aqueous solutions. Example for this any types of an acid, base, yeah, salt. That is the transfer of electricity. Okay, that is the aqueous solutions. Okay, allow electricity current to flow the freely. Then second one is the semiconductors, dropping the theory. Okay, dropping theory are part, that is the parts of dropping theory of semiconductors. Two types of semiconductor are present. First one is N type, second one is the P types. Okay, N types and P types semiconductors. So addition of your phosphorus in fifth groups. Phosphorus are added for this one fifth group. That is where chambers are present 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 types of structure are present. Then phosphorus are added for this one center point. So that is the N types of conductors and P types. Okay, means to any others, means that is using for these third groups. Periodic tables are present for this where 1, 2, 3, 4, 5, 6 groups are present. So that is why represent for the third group means boron and aluminiums. Okay, borons and aluminiums are added for this your center side. That is the parts of your P type semiconductors. And next one is your non-semiconductors are insulators. Example for this were rubber. Okay, that is the elastic forms. Any types of rubbers are not semiconductors. Non-semiconductor are insulators. Second one is your woods, yeah, fibers, then papers and non-metals. Except for this were carbon and sulfur. Okay, that is your non-semiconductors. Yeah, insulators. Okay, so then next one is the oxidation and reduction. What is the meaning of oxidations and reductions? And this one are using for these all the chemical reactions for the oxidation reductions. So oxidation and reduction for this oxidations and reductions. Both chemical reaction are present for the any one single reaction. This called is a redox reaction. Oxidation reductions. Okay, reaction are the chemically process involving the transfer of electrons. That is what transfer of electrons transfers. So which types of transfer of electrons I mentioned for this next examples. Okay, so oxidations means and reduction means oxidation means loss of electrons, gain of oxygens and loss of hydrogens. Generally, I mentioned for this word first one is the loss of electrons, is your oxidation. Second one reduction means gain of electrons, I would say aid of electrons, loss of oxygens and gain of hydrogens. So you have mentioned on for the gain of electrons. Okay. So different types of examples are present and no, no, that is what okay. One key point. So you can see for this key point OIL means oxidation is loss. Okay, OIN means oxidation, O means oxidations, I means in, L means loss. Oxidation in loss. Reduction means RIG. Reduction is gain. Okay, reduction is gain. Okay, so that is the key points. So I have mentioned for this for examples oxidation and reductions. So first one is the oxidations. Oxidations, reactions. Okay, example for first example for this were copper. Copper in a present for this room temperature in types of temperatures are present. So copper are removed for this over two electrons in outermost shell and two electrons are removed. This one is the remove of electrons. Okay, remove of electron. Which electrons? Two electrons are removed in your copper molecules. So that is our oxidation process. Second example is your zinc. Zinc is a remove for this word two electrons. That is our oxidation process. Next one is your silver is a remove for this word two electrons plus two charge plus two electrons are removed. Next one is your mercury. Okay, example for this word mercury. That is a remove for the electrons. So Hg plus 2 charge plus 2 electrons are removed. Okay, so different types of forms are present and different types of chemical will be used for this electrical energy, and chemical energy means electrochemical cell and electrolytic cells. Okay, that is the parts of our oxidation process, means remove of our electrons. Okay, remove of electrons. So remove of electrons. Second one is your reductions. Okay, reductions mean gain of electrons. Next one is your reductions. Reductions, reactions. Reduction means gain of electrons, means just opposite. Okay, plus 2 charge plus 2 electrons are 8. Okay, this one aid of electrons, aid of electrons. Then second language is your gain of electrons. Okay, so that is a converting for this your copper. Okay, Cu forms. Next one zinc plus 2 charge plus 2 electrons are 8, and this one is a converting for this word zinc, Zn. Okay, that is a converting for this word Zn. Next one where silver, sorry, silver plus 2 electrons are 8, and that is a converting for this word silver solid form. And next one is a mercury, Hg plus 2 charge plus 2 electrons are 8, and that is a converting for this word Hg. Okay, so that is an example for this oxidations and reductions process. Oxidation means remove of electrons, reduction means gain of electrons. So that is a complete for this your electrochemistry for the basic knowledge. Okay, next classes I'm discussing for this your battery technology. Okay, next topic is your battery technology. Okay, thank you all of you. Thank you.